Yeah. Oh, did you finish? Yeah.
No, not yet.
Are they not? Yeah, on it.
Yeah, so they were just well, it was we just switched to I got so attached to the interesting talk.
Okay, so on this outcome, we are doing the same stuff and we're combining it with actually some grade 10 stuff. Which means your brain probably forgot that, right? Okay, what does, anybody know what this does when you graph it? Y equals mx plus b. A line. It's a line. Okay, and it's called slope-intercept form, this way of doing it, because what do we know about m? It's a slope. Right? This is grade 10, does that ring a bell? Slope. And what else do we know about slope? Rise over run. Okay. And the b is the y-intercept, but we're not going to be probably worrying too much about that because we're going to be doing a lot of stuff with slope, right? And this is called slope point form because it gives us the slope, rise and run. And this is a point. Okay? And every time we have equations, do you understand we always have y's and x's and that we leave open as a y and an x? Okay, we also, I should have probably put this on here. Do you know what the word parallel means? We should maybe write that down. Parallel? If I talk about two parallel lines, what could you tell me about what you know for sure? They never touch? Specifically, what do you think their slopes would be like? The same? And perpendicular would visually look like this. And then what do we know about, anybody know anything about perpendicular slope? Right angle slope. The slopes are going to be negative reciprocal. So if this one's heading upward, this one's heading downward, right? One's going to be positive, one's going to be negative. And then what does the word reciprocate something mean to you? Fractionally, you turn it around. So if this is 3/5, this one's negative 5/3. Okay, so that's all stuff you did in grade 10. Okay, and we obviously know tangent line, derivative, slope. We know that stuff. And this word you're going to see, normal. The normal line is just the fancy word for the perpendicular line. Okay, number 1. Find the equation of the tangent line at the point 2, 8. Okay, so what I'm first going to do is derive, because derivatives give me slopes. So we get okay, 6x minus 2, is that your equation? So what is the slope at x equals 2? Because I was given the point. So what is going to be the slope right there? Okay, so we have the slope and we have a point. So, are you okay if I pick this format, slope point, because I have a slope and I have a point? Okay, so you don't need to write this, I'll just do this for filling it in. How do you fill in? Okay, so slope, the rise is 10 and the run is 1. You don't need to write a 1 there. I'm okay if you just don't write a 1. X subtract 2 and Y subtract 8. That's it. That's the slope. And then I filled in the point. Okay, now write the normal line. So the perpendicular line. So what is the perpendicular slope? If this was 10, our perpendicular slope is -1 over 10. Okay, I negated it and I flipped it. So that equation will be -1, x minus 2, 10, y subtract 8. Okay, I use the same point because it's going to be going through the same point. All right, number 2. Find the equations of the tangent and the normal. So we're going to do both. So let's start with the slope. Can you derive? So I'm going to get 3x squared minus 4x, right? Okay, what is the slope at 3? Okay, I got 15. I don't know. I'm just going to write it over 1 to make everything easy because we know that we'll be working with a rise and a run. Okay, so I have a slope, but something is going on. I don't quite have a point, right? I only have the x coordinate. So I would like a point. 3, comma. And what do I do to get that coordinate? I'm going to have to plug it in, right? Do you understand I'm plugging it into the original, not the slope? I'm not plugging it into the derivative. So y equals 3 cubed. I got 9, if anybody else got that. 3, 9 is the point. Okay. So my tangent and my normal, we got to do an equation for each. So I'm going to do a tangent one and a normal one. So my tangent one will be 15 x minus 3, 1, y minus 9. And the normal will be that, but then the slope, what do we have to do with the slope? We're going to negate and flip with a -1 over 15 slope. Okay, you know what I'm going to do? I'm going to graph this to show you like what is even really going on here. Okay, so the first, our equation, we have a cubic function, right? Remember what cubics look like? That's our cubic function. And then we went through the coordinate 3, 9. Okay, so that's where we went through. So the tangent line had this equation, 15 x minus 3. Do you see that that line is tangent? I don't know. Can you see it? Is it clear enough? I don't know. See that tangent line? Okay, and then if I do the perpendicular line, that's what it's talking about. Okay, so it's a perpendicular line that goes through that coordinate. Okay? Alright, I think I got at least one more example. Yeah, one more, and then we're done. Find the equation of a tangent when it's parallel to that line. So this is a parabola. There's a parabola, and then I have this equation, which is like a line somewhere completely else. And I want to figure out where on my shape I'm going to have a parallel tangent to that one. Okay, so let's derive this. So 4x minus 5 is the slope equation, the tangent slope equation. I need to figure out, where am I ever going to have a slope of what? What is going on? I need to have my tangent line parallel to that line. So if I'm going to be parallel to that line, what's the slope of that line? The slope of that line is 7. What do I know if I want to be parallel to it? What should my slope be? Also 7. I have to figure out, when am I going to have a slope of 7? So here's what I'm going to do. I'm going to say, when is my slope 7? Okay. So I'm going to add 5, divide by 4. Okay, so when x is 3, I have a slope of 7. Didn't really draw this realistically, but all right. So now this other line and my tangent line are going to be parallel. I need a coordinate though. 3 comma what? That's the point that I'm going through. Okay, so how do you get this? What are you going to plug it into? 3 comma, you're plugging it into the original equation. So 2 times 3 squared minus 5 times 3. Okay, I'm getting, I think, a 3. Okay, so my final equation, find the tangent line. So I have a slope of 7 and I have a point, 3 comma 3. So can you give me an equation now that we know the slope and the point? Okay, so I'm just going to show you here what was all going on. This one will be a better visual, I think. So 2x squared minus 5x. So we have a parabola. Okay, that's what that is. Then you had the line y equals 7x plus 13. Okay, so you had this black line. You wanted somewhere on your curve to also have that same slope. So we discovered that at x equals 3, it would have a slope I don't know if you can see it with this black line is somewhere else, and now this line is tangent, and it also is parallel to that line. Okay? That's it.